Chapter 2, Lesson 3 of Advanced Algebra, looking at elimination in solving a system algebraically. Now, elimination is actually an application of the addition property of equality, which says if we add additive inverses, the answer is 0, or the sum is 0. If I were to add 3x to its opposite, negative 3x, so 3x minus 3x, the answer is 0. Notice that the variable has been eliminated. I now have a term of 0. Now, a special note here, an important note. Remember, when you're adding 3x minus 3x, you get 0. You don't get nothing. It means there is something there, and it is 0. So you have to write the value 0 in there when you do that. Now, in order to do that, we need to have opposite terms. Now, we can create equivalent systems or equations that are equivalent by multiplying each term in the equation by the same number, and we may need to do that in order to create these opposites. So it is possible that if no terms are opposite, that we can either multiply one equation by a number, meaning we multiply every term in that equation by a number, which makes one of the variables opposites, or I may need to multiply both equations, one equation by one number and the second equation by a different number, but always doing it in such a manner that it creates two terms that are opposites when I add those together. So let me give you an example very quickly. Here we have this system of 4x minus 2y is equal to 7 and x plus 2y is equal to 3. Now notice that these two terms right here are opposites, negative 2y and 2y. So if I were to add those together, that would add to 0. So because that's the case, I'm going to use elimination. So in doing that, we notice that they are inverses, so we're going to just add the two equations together. So the 4x and the x is 5x. These two are inverses, which means it's 0. Now it's not nothing. This would be plus 0, but that's going to be 0. That's why I didn't use it in this case, because 5x plus 0 is still 5x. And then equals 10, so then we just have the variable y eliminated. We solve for x, we get x is equal to 2. Now again, we're trying to find the ordered pair, so I need to know what y is. So now that I know what x is, I can choose either one of the original two equations, substitute that value in for x that I now know is 2, and get the y value that would be the corresponding y value. So substituting in 2, I get a y value of 1/2. So remember, we're solving for an ordered pair, so my answer needs to be in an ordered pair. So the solution for this system is 2 and then the y value of 1/2. Now that one's kind of easy because these are already opposites. But what if they're not opposites? We talked about multiplying the equations by a number that creates opposites. So you'll notice that none of these terms are opposites, so I'm going to create opposites. I'm going to multiply this top equation by a number and this bottom equation by a different number, making sure that as I do that, either the x's will end up being opposites or the y's will end up being opposites. And again, it doesn't matter, it's whichever one you're comfortable with. So in this occasion, they decide to make the y's opposite. So if we multiply the original first equation by the number 2, so we multiply every single term by 2. And this is important, you have to multiply every term by 2, not just the one you're trying to make opposites. Then if I choose to multiply the second equation by a negative 7, notice that creates these opposite terms right here, which when I add them together is going to equal 0, thus eliminating the variable y. So once I've done that, I go ahead and add those two equations together. I get negative 28x. The y value is 0, or the y term is 0, leaving me the y eliminated, and then I simply solve for x. X is equal to negative 2. I then go ahead and substitute the x value back into either one of the original two equations. It does not matter which one you do. So we substitute that negative 2 in and then solve for y, giving me the y value of 3. Then again, we are solving for a point who has an ordered pair, so we'll put that in ordered pair form. So the solution of this is negative 2, 3. So that's elimination. Now, a few comments about how to decide which one and which one's the most valuable or the best to know how to do, perhaps. So given the choice, how do I choose between substitution and elimination? Now, on some problems they tell you to do substitution, you must do some substitution. On other problems they say use elimination, you must use elimination. But if you're given the choice, which one should you use and why? So some tips to remember. The first thing to do when looking at your system is to look and see if there are any opposite terms. If the terms are already opposites, elimination is going to be the easiest. So jump right in and use elimination. The second thing to look for, if they aren't opposite terms, is to check for ones that are almost opposite terms, meaning maybe they're both the same, it's just that one's not negative. Well, if that's the case, then again, it's real easy. If you change every term sign or multiply by -1, then again, elimination makes the most sense and is the quickest to do. Check if none of those are true, then check for coefficients of 1, because if you have coefficients of 1, then substitution is going to be your best method, because then you can simply solve that equation for that variable that has a 1, and then you can use substitution. If number 3 is not available, then you'll want to use elimination. And then that's going to be when you multiply both equations by the same value or by values that create opposite terms. So notice there's 3 things to check before you end up having to do this. So check for these 3, and if any of these 3 are available, use those. Number 4 is probably kind of a last resort type of thing. Now, it is important to notice that elimination is most often the best choice. There aren't going to be many situations where you have a coefficient of 1. So therefore, you should become very familiar with this method. It is the more useful of the two, because this number 4 step you can really use for any system, and so it really is the one that you'll want to use the most often. But again, if you check these other choices first, then you can eliminate maybe this having to multiply everything, which would probably reduce errors because you're not multiplying everything that you need to do by that. One final note then about word problems, and that is to remember this, is this lesson is on systems of equations, so you're going to need to create a system, meaning when you read a word problem, you're looking for 2 linear equations. You're going to have to write 2 linear equations. So you're going to have to, again, look in the problem and try to create those 2 linear equations from the information that's given. Once you have the system, you're looking for the intersection point. So in that case, graphically is probably the place you want to go first, because word problems generally don't come out to a nice even number. And so solving graphically is usually the quickest and easiest way to get that intersection point. So again, use those skills that we have been using, or we talked about and taught you in class. So graphically is probably going to be the easiest thing to do.